Today, I'm going to discuss Newton's three laws of motion. His first law states that objects in motion tend to stay in motion, while objects at rest tend to stay at rest. We can state this somewhat more concisely as objects tend to maintain their velocity, or equivalently, momentum is constant. For this reason, the first law is referred to as the principle of inertia, inertia being another word for momentum. This just means that a moving object will keep moving. For example, let's say we have a boulder sitting on a hill. This boulder will be really hard to move. In fact, if it were up to the boulder, it would just stay sitting on top of that hill forever. However, let's say the boulder does start moving, and now it is rolling down the hill. Just as it was difficult to get the boulder rolling in the first place, it will be similarly difficult to get the boulder to stop rolling. In fact, if you tried to stop the boulder, it would most likely end up killing you. This is the idea of the first law. Objects want to maintain momentum. However, eventually, the boulder rolling down the hill would stop. This is where Newton's second law comes in. It states that the change in momentum in a given time is equal to the force on an object. So forces are what cause objects to start, or stop, moving. Now, in life, it may seem that objects just stop moving, with no forces acting on them. This is untrue. There are just a lot more subtle forces that generally go unnoticed. For example, the boulder does not have any obvious forces acting on it, so how does it stop? There are actually a few forces acting on it, the forces of friction and air resistance, among others. In fact, most objects stop moving due to these two forces, friction and air resistance. It should be noted that change in momentum in time is generally equal to the acceleration of an object times its mass. So force equals mass times acceleration. This can be written mathematically as F equals m times a. Since acceleration is change in velocity, this matches up with what I've mentioned earlier. The third law makes a further statement about forces. It says that for every action, there is an equal and opposite reaction. So, if there is a force acting on one object by a second object, then there is an equal force directed in the opposite direction acting on the second object by the first object. While this happens in every situation, certain scenarios make it easier to visualize. For example, let's say you jump off a boat to the shore. To jump off the boat, your legs have to exert a force on the boat to push you up and in the direction of the shore. However, there is an equal and opposite force acting on the boat. The boat also pushes off your legs, moving in the opposite direction of the shore. Newton's third law is the reason boats move away from you when you step onto the shore, or a dock. Now, while it is easier to see in the case of the boat, it happens in every situation with forces. In the case of the boulder, the earth exerts frictional forces on the boulder, causing it to stop. Similarly, the boulder exerts a force on the earth in the opposite direction. So the boulder causes the earth to move by a bit. It should be noted that this is equal and opposite forces, not equal and opposite accelerations. So the reason we don't see the earth move by a bit when the boulder stops is that the earth has a lot more mass than the boulder. This goes back to the second law. It should be noted that the conservation of momentum can be derived from this third law. Since forces are equal and opposite, and force equals change in momentum, the change in momentum of one object equals an opposite change in momentum of a second object. So in this way, momentum is conserved between those two objects. These three laws provide a near-complete description of the behavior of forces, and started the development of classical mechanics. Nevertheless, hope you enjoyed it, hope you learned something, and see ya.